Hello, this is the next video in a playlist that I'm calling Hypothesis Testing. And here we're in part of the unbiased hypothesis testing phase of the playlist. And now we're looking at uniformly most powerful unbiased test. And previously we looked at simple versus composite UMPU tests. And now we're looking at two-sided UMPU composite versus composite tests. And we're going to do several examples. This example deals with the normal mean, which is the previous video of this playlist where we develop sort of the theory and the background of what we're going to do in this video. Here we're just going to use R to solve for the rejection region, the critical region. Here it's a composite versus composite hypothesis testing, and I call it two-sided. Maybe it's three-sided. I don't exactly know. I think they call it two-sided. Where we're testing the null hypothesis is the mean between two values, and the alternative is it less than mu1 or is it greater than mu2. And let's just jump right in. So here I like to clear all the objects from my list. We're going to have a sample size of 22, mu1 of 7, mu2 of 8. So the null hypothesis is that mu is between 7 and 8, and the alternative is that it's less than 7 or greater than 8. We're going to assume we know the population variance, which is 9. We're going to conduct an alpha 0.05 test. And in the previous video, we showed that this is the function that we need to solve for C1. So it's a function of C1 by itself. And yeah, so this is it. So then we use the uniroot function where A is alpha and C is this critical region. So we want the alpha minus that critical region to be 0. So we raise and lower C1 till we find that value. And uniroot does that very efficiently. And we're done. So then we use C1 to find C2. And then our critical regions are 5.9 and 9.1. And that's it. So now let's develop a power function based upon these cutoff values. So we'll take C1 and C2 and put them in this function. And then let's plot it and see what it looks like. And this is it. So notice that the vertical bars deal with 7 and 8, and so between there's our null hypothesis, and so the power curve is below 0.05, which is that horizontal dotted line, and it increases to 1 as we go left or right of that, or we get further into the alternative region. And that's it. I mean, that's so fast and easy to calculate. So here's is a forget one side or forget one tail test, and here we calculate C1 and C2 just on the one-tailed test. So we look at the left tail assuming mu1 is the true value, and Q norm very quickly finds that value. And I don't know why I have alpha over 2. It should be alpha, and then this should be, we look in the right tail to be alpha, assuming that mu2 is a true value. And then C1 and C2 are the UMPU critical regions for that test. And this is for the one-sided test. Look how close they are, right? Because once you start getting into one of the alternative regions, then the probability of being in that opposite tail is so small that it doesn't really factor into what we're doing here. So we develop a power curve based upon these cutoff regions, and then we add it to the previous curve, and we look at it and notice that it looks almost on top of each other. It's almost the same curve. It's not quite. It's an approximate UMPU test. So let's zoom in once and see if this is going to be enough. May or may not. And it's not. So on my screen I can kind of tell that they are starting to separate, but it's ever so closely. I could zoom in on one of these one of the critical regions, 7, and really zoom in and make the difference known. But you get the point that it's really close if you just use the leave one tail out test. So, well, that's all I have for this video. As always with my R code videos, I copy and paste the code into the comment section, and I try to pin it so it's always at the top so you can copy and paste the code into your R program. So I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.